In this series, we're going to look at measuring. This will be conducted under the Australian and New Zealand Standard of Measuring. This standard is recognised worldwide, but please check your local building code for any differences. We're going to follow a certain project all the way through. Today's video is external wall cladding. If you've enjoyed this video, please don't forget to like and leave comments below. So now we're looking at the exterior cladding. There's a number of components involved in this, everything from the building wrap, as you can see highlighted here, which is a dotted line that's secured to the timber stud framing. And then you've got the 20mm cavity battens. We'll go into the spacings all in those in a little while. And then you've got the flashings in between. So you've got a flashing, you've got a corner flashing here. We've also got flashings on every cavity, on every joint of the exterior cladding as well. Plus we've also got all the cover boards on the corners there. Plus we've got the horizontal closure flashings, which we'll go into. So first we're going to be looking at the underlay. So there's a specific underlay that's required here. The supplier and fit a mason's wall underlay, including all fixings. So the fixings for this underlay would literally just be staples. So we're going to be stapling the underlay to the stud wall. And it's just a matter of measuring all the way around. So we don't cut out for openings. The reason why we don't do this is because it comes in a big sheet form. So you have to buy it regardless of what you're cutting out. And we're going to be using some of it within the frame anyway. So you cover the product all the way around the walls, and we cut a hole inside the opening, and we actually tuck some of it within the framing as well, because we need to protect that frame. So we'll do the measurement for that. So we know from this point to this point here is 12.95 meters. So we've allowed that for the first one, and the height from the base to the top is 3.43 meters. So we've allowed that, and then we just apply the one, giving us a total of 44.38 square meters. And on the other side of the building, because this building's got a pitched roof, because this building's got a monopitch roof, meaning it's only got a one slanted roof, the other side is lower than this side here. But the length still stays the same, so it's still 12.95, and the height is 2.88, and it's just one of those, so we get a total of 37.23 square meters. So next we look at the side. So this is where we've got the mono pitch here. So we've looked at the first measurement was for this side, the second measurement was for that side at the front and the back. The product all the way around the walls, and we cut a hole inside the opening, and we actually tuck some of it within the framing as well, because we need to protect that frame. So we'll do the measurement for that. So we know from this point to this point here is 12.95 meters. So we've allowed that for the first one, and the height from the base to the top is 3.43 meters. So we've allowed that, and then we just apply the one, giving us a total of 44.38 square meters. And on the other side of the building, because this building's got a pitched roof, because this building's got a monopitch roof, meaning it's only got a one slanted roof, the other side is lower than this side here. But the length still stays the same, so it's still 12.95, and the height is 2.88, and it's just one of those, so we get a total of 37.23 square meters. So next we look at the side. So this is where we've got the mono pitch here. So we've looked at the first measurement was for this side, the second measurement was for that side at the front and the back. So now we just look at the sides. So we've got 5.85. So that's from this point here to this point here. And the height from the base to the top here is the 2.88, which is the same as the second quantity that we've got here. And then what we do is we do a triangle to fill the rest in. So if it was just the one triangle, we'd be doing 5.85, the length, times whatever the difference in height is. In this case, we can see it here, it's 0.552. So you do 5.85 times 5.552. And if it was just the one side, we'd be putting a 0.5 there. But because there's two sides, we apply 1, giving us 3.23 square meters. And then we add on our extra value for wastage, gives us 11.85 with a total of 130.33 square meters. So next is the cavity battens. So we need to supply and install the cavity battens here, which you see. It acts as a barrier, an air barrier between the stud wall and the exterior cladding. And we need to put these vertically at 600 mil centers. So we've got a 45 by 20 H 3.2 timber cavity batten at 600 centers with fixings. So we need to do a roundup calculation to find out how many vertical battens there are and divide it by the spacings and times by the height. So we take this first calculation, which is the length of the face, which is 12.95 from here to here, and we divide it by 0.6 because that's the spacings, and the height we know is at 3.43, so we times that by whatever the number of battens are by 3.43, giving us a total of 75.39 linear meters. Now we don't take out the windows. The reason for this is we're still measuring the cavity battens in here. Yes, we will cut them off for the opening, but we'll need to apply them to the sides, and we'll also need to apply them to the top. So if we allow for the cavity battens to be in here, that will cover us for putting the cavity battens around the openings. And then we go to the other side of the building, which is still 12.95 divided by 0.6, and we know that they are 2.88 that high on that side. So it gives us a total of 63.25. So then we go to the side of the building, which is 5.85, which is the width of the building here. And then we divide that by the 0.6 spacings and times that by 2.88, which is the height we have here. And then also we have to do the small triangle, which we're not allowed for. So that we know it's at 5.85 and with 600 mil spacings. And then also we times that by 0.55. So there's two of them, so we just allow for the one. We also have horizontal cavity battens. So we've got one running across the bottom here and one running across the top here. And that's also on the other face as well. So we've got a 12.95. There's two battens. You've got one at the top, one at the bottom, and you've got two faces. And also with the sides, we've got a 5.85, two battens, two faces, with an extra 10% of 27.69 linear meters, giving a total of 304.55 linear meters. So we also have a 20 mil cavity closer. So this allows the cavity to breathe. So this is similar to what we have for the timber one, but it's either made out of metal or plastic, and it has holes cut into it to stop any vermin getting in, and also to allow air to go through the cavity, because although we're using an exterior cladding, we're protecting it, water will still get in. It might be condensation, it could be the water penetrating through the board, so we need to remove that water content from the cavity. So we put a cavity closer in, and again we'd go through the width, which is a 12.95. There's only one of them, but we have two sides, and then for the sides we have a 5.85. Again, there's only one of them, and that goes at the bottom, and there's two sides. So next we look at the flashings. So we've got 100 mil UV resistant back flashing, which goes on all of the battens, and this gives a separation between the exterior cladding and the batten. So the back flashes are at 12.95 divided by 0.6 times 3.43. And then you've got the opposite side at 12.95 divided by 0.6 times 2.88. And then we've got the two sides at 5.85 divided by the 0.6 times 2.88. And then you've got the little triangle at the top, which is 5.85 divided by 0.6 times by 0.552. And with the extra waste, we got a total of 221.28 linear meters. So we also have corner flashings. So we've got a 50 by 50 diner flashing here. So that covers off the opening on the corner. So that will be fixed to one batten on one side and a batten on the other side. And the weatherboard goes over the top of that with your corner boards covering those as well. So we have a minimum of 50 by 50 diner flashing to weatherboards. This is a vertical joint with fixings and silicone bead just to seal it off. So the diner flashings, the height on the tallest area is 3.43. There's going to be two of those in the front, and then you've got the 2.88 with two of those at the back. With our wastage, we get a total of 13.88 linear meters. So next we have the weatherboard. So as you can see here, it shows you where the weatherboard goes. They're only a 150mm wide board. You'll have a flashing where there's a cavity batten, but there's also a weather groove jointer with a back flashing on there as well. So what we do is we allow for both. So we'll get into the weatherboard first. So what they're asking for is to supply and fit 150mm WeatherTex weather grooved Woodsman 150mm panel with fixings. So with the larger side, we've got a 12.95 times 3.43, and there's only one side of those. With the opposite side, we've got a 12.95 times 2.88, and there's only one of those. And the sides, we've got a 5.85 times 2.88, and there's two of those sides. And next we need to look at the finished triangles at the top, which is a 5.85 times 0.552. And if there was only one side, this would read 0.5, but as there's two sides, we say 1. And then we just take out the deductions for the window openings. So we've got window W1 and W3, W2, W4, W6, W8, and W5. We won't be covering over those like we do with the building wrap because these come in set lengths planks, whereas the building wrap is a big long sheet. So with the wastage, it gives us a total of 109.11 square meters. So next we've got the weather groove jointers to all joints on the exterior cladding, including fixings and sealants. So this is this joint here. So there's no batten behind it. So we have to have a jointer in there to seal that jointer off. For this weather groove jointer, we've got a 12.95 divided by 0.15. That gives us the amount we need, and total the height, which is 3.43, and that gives us a total amount of linear meters for that wall. And then for the other side, it's 12.95 divided by 0.15 times 2.88, and that gives us a total as well. And then for the ends, we've got a 5.85, 0.15 times 2.88, and that's times 2. So in this calculation, I'll have a 2 on the end, a times 2 on the end, because you've got two ends. And then to finish off the little triangle areas, we've got the 5.85, 0.15 times 0.552. And again, we'll just do that as a one calculation. If it was only one side, we'd have a times 0.5 in here, but we don't. And that gives us a total of 873.46 linear meters. And then finally, we've got the cover boards. So these are the boards that go on the corner here. So we know there's 4 corners. So it's just a matter of working out the heights and working out the number of boards. So there's 2 boards per corner, and we just apply that to our spreadsheet. So we've got a 90 by 19 H 3.2 cover board with 6mm weather grooves to build in corners with fixings. So the weather grooves, the 6mm weather grooves are these slots in here. So they just allow it all to breathe. So cover board one side, we know one end is 3.43. We've got 1 at each end, and there's 2 per corner. And the other side, we've got a 2.88. Again, there's 2 at each end, and we've got 2 per corner, giving us a total of 27.73 linear meters. Thank you for watching. If you've enjoyed this video, please like and leave comments below. Please stay tuned for future videos on quantity surveying elements.